Thank you for watching this introduction video about the release of the new DHAtoD86 tool by StillPeaks. My name is Walter Spieksma and I'll talk you through this introduction video. The DHAtoD86 chemistry can be found in this article in the Journal of Chromatographic Science. Distillation includes several phenomena like boiling and condensation to a thermometer tip. These phenomena are all modeled in the new tool I will present to you in this way, where you can see all the relations between mass transport and the composition of the phases. A typical starting point is where you open the software on the bottom of your screen and you have your integration peaks on the top of your screen. It is very important that all your peaks are integrated correctly. And then you can look up your samples in the software, like for example, if you use ChemStation, you can look up your sequence and then you can get your data, like you have all kinds of data. The N paraffins are recognized and peaks are identified on the fly as you look here. This is an alkylate sample, and I can show you one. Please note that all these retention times are only 4 to 5 minutes, so these analyses are really short. And I would like to show you one of those. Here we have a green gasoline. The green gasoline contains ethanol. And when we look at the 86 curve, you can hit the run button and you see there is a really big peak of ethanol. This really big peak of ethanol is disappearing, and once it has disappeared out of the flask and out of the vapor and away from the thermometer tip, then the curve starts to occur like it always occurs in hydrocarbon only samples. But in green gasoline you have that typical plateau where the boiling point of ethanol is at 80 degrees Celsius. So this plateau is much lower. And then we see that there is actually only one outlier, and that is at the 40% point. I can show you another example. That is this one. This is typically a gasoline with isomerate in it and MTBE, and it's also an ASTM cross-check sample. And when we use the same sample specific set points, like the sample temperature should be 5 degrees Celsius and the heater before IBP is 350 degrees Celsius, then we get also quite good results for this more well-behaved gasoline. Well, we wait for the final report, and there it is. And we have 11 points are on spec, except at 20 and 30%. There, these differences are significant. Well, I would like to show you something else, because here we have those retention times, and here we have index, and index always needs N paraffins. And when we change the N paraffins, we can also look at a different sample that is an artificial gasoline, and I really would like to show that one. It is a mixture of gasoline and N paraffins and ethanol, and when we hit run we get the following picture. You see that again ethanol is dominant in the flask. It disappears at some point, and then the rest of the curve is really taking a bend up. And even though the difference is 11 degrees in volume, the difference is only very small. We talked you through our latest StillPeaks DHAtoD86 tool, which is easy, safe, accurate and fast. Thank you for taking the time to watch the complete introduction video. Please give us your feedback on our DHAtoD86 tool. We will be releasing a beta version soon. When you're interested in becoming an early bird user, please sign up via our contact form or email us.